Okay, friends, here's another one for us in related rates. So what's happening here? We've got a Toyota Corolla, a nice Reliant automobile, is traveling west at 50 kilometers an hour, and Subaru Forester is going north at 60 kilometers an hour. They're both heading towards an intersection. At what rate are they approaching each other when the Corolla is 0.3 kilometers away and the Forester is 0.4 kilometers away? All right, well, as always, let's draw ourselves a pretty picture, right? So what do we got going on here? So the Corolla is traveling west towards an intersection. So there's our intersection. So the Corolla is coming this way, and the Subaru Forester is going north, going that way. And we want to know how fast are they approaching each other? Well, how fast they're approaching each other would be that right there, the distance between the two cars. So what I'm going to again do is I like to label my things in terms of the Cartesian plane. So I've got the Corolla coming this way. I'm going to call that X. This is the, what is it? The Forester. And then the hypotenuse, I mean, you could call it H, but I like to just go X, Y, Z myself. So what is it again? I know. So what do we know, friends? Well, what I know is that dx dt, the Corolla, is traveling west at 50 kilometers an hour. But the thing I want you to keep in mind is that this is actually negative 50. And the reason is because they're coming towards the intersection. That distance is decreasing, so it's negative. dy dt, that's the Forester. And that's negative because it's coming towards the intersection. That distance is decreasing. All right. And what do we want? We want distance between them. How's that changing? So dz dt is equal to question mark when, and it says when the Corolla is 0.3 kilometers away from the intersection, and when the Forester is 0.4. Okay, there we go. So from here, what's our formula we're going to use? Well, again, I see myself a pretty right triangle. That just screams good old Pythagorean, right? Let's go for this pretty color here. So x squared plus y squared, z squared. Now I say to myself, I take the derivative of x, I get dx dt, that's good. Derivative of y, dy dt, derivative of z, dz dt, I'm good to go. I've got everything so far. So I take the derivative with respect to time. So that's why we really, again, had to learn implicit differentiation way back when, like that. And then I'm going to say to myself, okay, well, I'm going to divide everything by 2, and let's start subbing in numbers at the same time. So I divide everything by 2, okay, and let's start subbing in what we know. Okay, well, what do we know? We know x is 0.3 kilometers. dx dt was what again? Negative 50. And y is 0.4, and dy dt was negative 60 because they were approaching the intersection. But z, oh no, like I want dz dt, but what's z? Oh no, big deal, because look at, we know when x and y. So again, I go back to the formula that we had created, which was this. And I'm going to solve for z. So I sub in when x is this and when y is this. And I'm going to say what's z. Okay, that's a Pythagorean triplet. I'm hoping you can maybe see that, and you trust me that that's going to be 0.5, positive or negative, but we're only going to include the positive, right? And so now again, we go and we can sub that value in right there. And now, friends, all we've got to do is just solve this thing. So what do we get here? We're going to get, this will be negative 15. This will be negative 24 is equal to 0.5 dz dt. And again, you could have rearranged the formula first if you wanted to. What's that? That sounds like negative 39. And dividing both sides by a half. That's the same as multiplying by 2. And what's double 39? Sounds like negative 78. All right. And there it is. So the distance between the cars is decreasing at a rate of 78 kilometers per hour when the one car is 0.3 kilometers away and the other one's 0.4 kilometers away. There it is. Okay, so again, here's another kind of subtype of question you see all the time in related rates where something's approaching another intersection. And again, I just want to come back to the fact that these values here were negative because the distance to the intersection was decreasing. All right, another one down.